November 2018, paper 6, variant 1. A student obtains pure dry samples of sand and sodium chloride from a mixture of sand and sodium chloride. The student uses the apparatus shown. The method consists of 6 steps which are shown in the wrong order. Okay, order the steps in the method. Order the steps in the method. So first of all, he got the mixture of sand and sodium chloride. To separate a mixture of two solids, you must add a solvent that dissolves only one of the two solids. So the next step is C, okay? The next step is C, he added water and stirred. The following step is F, he filtered, he will obtain the sand as the residue and the sodium chloride solution as the filtrate. Okay, starting here, the order doesn't differ. You can say D, B, E, you can say B, D, E, you can say B, A, E, D, okay? It doesn't differ. The 3 steps are equal, okay? It doesn't differ the order that you do them in. In both cases, you obtain sand and sodium chloride solid powder. Okay, B, complete the box. This is an evaporating dish. This is an evaporating dish or basin, evaporating basin. C, why is the sand rinsed with water? To remove or to wash out or to dissolve the salt or the sodium chloride. Don't tell me the impurity, okay? You need to specify. You're rinsing the sand with water because the sand is, is wet with sodium chloride solution, okay? It is wet with sodium chloride solution. So you're washing out or you're removing sodium chloride solution. If you said that to wash out or to dissolve or to remove anything, you take a mark. If you said sodium chloride or salt, you take the second. Name the process in F. The process in F, of course, is filtration, since I see a funnel and a filter paper. How could the purity of the sodium chloride be checked? By melting point measurement, okay? You cannot say boiling point because sodium chloride is a solid. You will melt it before you boil it, okay? So you measure the melting point, it should be sharp. Just melting point takes the mark. This is the first question. The second question, okay? Student investigated the rate of reaction between nitric acid and lumps. Lumps means large blocks of magnesium carbonate, and the experiment is shown. Of course, he's measuring the rate by measuring the loss in mass, since he's putting the conical flask on a balance. And he told you a very important piece of information, which is that the magnesium carbonate was in excess, which means at the end of the reaction, magnesium carbonate will remain, which means the nitric acid is the limiting reagent. Limiting reagent means it's the acid that determines the final outcome of the reaction. You know, the mass loss is determined by the acid, not the magnesium carbonate, because it's in excess. Okay, the readings, here they are: 86.0, 85.0, 84.4, 84.1, 84.0, 83.9, 83.9, 83.9. You must take all the readings to one decimal place, since this digital balance, okay, is sensitive to one decimal place. And you knew that because you wrote 84.4 and 84.1. You can't write these and then write me 84 without 0.0. Okay, if you're taking any reading to one decimal place, every reading is taken to one decimal place. The total loss in mass is 0, 1, 1.6, 1.9, 2, 2.1, 2.1, 2.1, and then you'll draw the graph, and you will not pass by the point at 4 minutes. You will not pass by the point at 4 minutes, or else the graph will become a very strange one. Okay, this is an anomalous point. You don't pass through it. The graph in blue is the one we're talking about. Then he said the average rate of reaction can be calculated using the equation shown. The average rate is the total loss in mass over time taken, and he wants you to calculate the average rate for the first 30 seconds. You must do like this. You will come at 30 seconds, okay? He didn't ask to show your drawing on the diagram, but you will come at 30 seconds and hit the graph and read the reading. It will be 0.5 grams, 0.5 over 30, so the rate is 0.017 grams per second. Grams per second, that's the unit. It decreases by 0.017 grams each second. D, the experiment is repeated using an excess of powdered magnesium carbonate, okay? Powdered means that the surface area is higher, the frequency of collision is higher, okay? And therefore, we need to draw the graph steeper, but finishes off at the same level. Steeper, but finishes off at the same level, okay? That's why the graph has 2 marks. Steeper mark, finishes off at the same level mark. The graph in green is the one we're talking about. This is the one. Okay. Okay, why does the mass of the conical flask and its contents decrease? What causes the decrease in mass here? You're adding a carbonate to an acid. Whenever a carbonate reacts with an acid, carbon dioxide gas is given off. So it decreases because a gas is given off. Second, double I suggests the purpose of the cotton wool. The cotton wool's purpose is very important. It allows the gas to escape and prevents the loss of the acid. How is that? Here in this reaction, I only want to measure the rate that's resulting from the loss of the gas. So the cotton wool has pores in it that allow the gas to escape. But if the acid splashed, it will hit in the cotton wool and not leave the container, and therefore will not give me misleading results. Okay, so it allows the gas to escape, one mark, prevents the loss of the acid, the second. Why does the graph level off? Please take care. Never say only because the reaction has finished. You need to tell me which reactant was used up. Don't leave your answers mysterious, okay? Or make them always obvious. Reaction has finished takes a mark because the nitric acid is used up or all the nitric acid is reacted takes the second mark. Why didn't we say that the magnesium carbonate is used up? Because magnesium carbonate was in excess, okay? F, give one advantage of using a burette instead of measuring cylinder, it's more accurate. One disadvantage, the main disadvantage of the burette and the pipette is that they are slow. They are slow. Cations and anions, you have two solids, G and H. He tested the solid G lilac color. So lilac color means على طول the flame color, the flame test gave me potassium. Solid G was dissolved in distilled water. Test 2, dilute hydrochloric acid was added to the solution. The solution was warmed gently. The gas produced was tested with filtered paper, which has acidified potassium manganate. This is the test for sulfur dioxide gas. It turned from purple to colorless, so I have sulfur dioxide. That's the answer of A. And I have sulfur dioxide gas, which comes from which anion? Sulfite. And here I have potassium, so the salt is potassium sulfite. Okay. Finally, test in solid H. Solid H was calcium nitrate. Complete the expected observation. Solid H was added to distilled water. Okay, calcium gives white precipitate insoluble in excess. So I, white precipitate, double I, insoluble in excess. D, an excess of aqueous ammonia was added to the second portion of the solution. No change or no precipitate. I prefer no change. Okay, always when you want to say that nothing happened, say no change. Okay, ammonia with calcium doesn't give anything. Dilute nitric acid and equals silver nitrate. Silver nitrate is the test for halides, and I don't have a halide, I have a nitrate, so no change also. F, aluminium foil and aqueous sodium hydroxide were added to the fourth portion of the solution. The mixture was warmed and the gas produced was tested. The gas is ammonia. Ammonia gas test is a damp red litmus paper or red litmus paper, or even litmus paper takes the mark and the observation turns blue. Okay, this was a very silly investigation. Propanone and ethyl ethanoate are both solvents which can be used to remove paint. Plan an investigation to determine which of these two solvents is better to use to remove paint. And you're provided with glass slides and paint and the two solvents, okay? The first thing you'll paint the glass slides and you leave them to dry. So you have now glass slides with paint, a glass slide with a paint. Add drops of propanone till the paint is removed. You keep adding propanone drops till the paint is removed. And you count the drops you've added or you measure the volume you needed to remove the paint. Then you repeat with the same experiment with ethyl ethanoate, and the solvent that required less drops or lower volume is the better solvent. Okay? Every 1 point with a mark. Even if you didn't get the whole thing right, you can score good marks. You can use another method by measuring the mass. يعني you can add مثلا equal volume of propanone and ethyl ethanoate to the glass slides painted, and then you measure the mass before and the mass after, and the one which causes the highest loss in mass was the better solvent remover, a paint remover. This was November 2018 by Mr. Mark Madhat.